The count of confirmed exoplanets just ticked past the 5,000 mark, representing a 30-year journey of discovery led by NASA space telescopes. Not so long ago, we lived in a universe with only a small number of known planets, all of them orbiting our Sun. But a new raft of discoveries marks a scientific high point. More than 5,000 planets are now confirmed to exist beyond our solar system. The planetary odometer turned on March 21, with the latest batch of 65 exoplanets, planets outside our immediate solar family, added to the NASA Exoplanet Archive. The archive records exoplanet discoveries that appear in peer-reviewed, scientific papers, and that have been confirmed using multiple detection methods or by analytical techniques. The 5,000-plus planets found so far include small, rocky worlds like Earth, gas giants many times larger than Jupiter, and hot Jupiters in scorchingly close orbits around their stars. There are super-Earths, which are possible rocky worlds bigger than our own, and mini-Neptunes, smaller versions of our system's Neptune. Add to the mix planets orbiting two stars at once and planets stubbornly orbiting the collapsed remnants of dead stars. We do know this: our galaxy likely holds hundreds of billions of such planets. The steady drumbeat of discovery began in 1992 with strange new worlds orbiting an even stranger star. It was a type of neutron star known as a pulsar, a rapidly spinning stellar corpse that pulses with millisecond bursts of searing radiation. Measuring slight changes in the timing of the pulses allowed scientists to reveal planets in orbit around the pulsar. Finding just 3 planets around this spinning star essentially opened the floodgates, said Alexander Wolszczan, the lead author on the paper that, 30 years ago, unveiled the first planets to be confirmed outside our solar system. Wolszczan, who still searches for exoplanets as a professor at Penn State, says, "We're opening an era of discovery that will go beyond simply adding new planets to the list." The Transiting Exoplanet Survey Satellite, or TESS, launched in 2018, continues to make new exoplanet discoveries. But soon powerful next-generation telescopes and their highly sensitive instruments, starting with the recently launched James Webb Space Telescope, will capture light from the atmospheres of exoplanets, reading which gases are present to potentially identify telltale signs of habitable conditions. The Nancy Grace Roman Space Telescope, expected to launch in 2027, will make new exoplanet discoveries using a variety of methods. The ESA, European Space Agency mission Ariel, launching in 2029, will observe exoplanet atmospheres. A piece of NASA technology aboard, called CASE, will help zero in on exoplanet clouds and hazes. How to find other worlds? The picture didn't always look so bright. The first planet detected around a Sun-like star, in 1995, turned out to be a hot Jupiter, a gas giant about half the mass of our own Jupiter in an extremely close, 4-day orbit around its star. A year on this planet, in other words, lasts only 4 days. More such planets appeared in the data from ground-based telescopes once astronomers learned to recognize them, first dozens, then hundreds. They were found using the wobble method, tracking slight back and forth motions of a star, caused by gravitational tugs from orbiting planets. But still, nothing looked likely to be habitable. Finding small, rocky worlds more like our own required the next big leap in exoplanet hunting technology, the transit method. Astronomer William Baracchi came up with the idea of attaching extremely sensitive light detectors to a telescope, then launching it into space. The telescope would stare for years at a field of more than 170,000 stars, searching for tiny dips in starlight when a planet crossed a star's face. That idea was realized in the Kepler Space Telescope. A team of scientists found NASA's Nancy Grace Roman Space Telescope will be able to measure a specific kind of space dust littered throughout dozens of nearby planetary systems' habitable zones, or the regions around stars where temperatures are mild enough that liquid water could pool on world surfaces. Finding out how much of this material these systems contain would help astronomers learn more about how rocky planets form and guide the search for habitable worlds by future missions. In our own solar system, zodiacal dust, small rocky grains largely left behind by colliding asteroids and crumbling comets, spans from near the Sun to the asteroid belt between Mars and Jupiter. Seen from a distance, it's the brightest thing in the solar system after the Sun. In other planetary systems it's called exozodiacal dust and creates a haze that obscures our view of planets because it scatters light from the host star. By studying exozodiacal dust, astronomers can find clues to what other planetary systems are like. The amount of debris hints at comet activity, since a greater number of comets should produce more dust. Seeing the dust's distribution pattern could offer hints about orbiting planets, which could sculpt the debris with their gravity and carve paths through the material. While other observatories, such as the Hubble Space Telescope, have observed cold debris disks far from their host stars, farther from their stars than Neptune is from the Sun, no one has been able to photograph warm dust in the habitable zone region. While previous NASA projects have made preliminary measurements of exozodiacal dust in habitable zones, Roman's images will be much more sensitive, thanks to its advanced high-contrast coronagraph instrument and its stable location in space. Orbiting 1 million miles from Earth around the Lagrange point 2, L2, instead of in low Earth orbit like Hubble, means our planet won't present such a challenging environment from which to make these observations. Imaging warm debris closer to host stars is important because it's made up of different material than outer dust disks. Closer to the host star, rocky grains dominate the dust; farther away, it is largely composed of icy grains. The debris in each region is created by different processes, so studying the chemistry of exozodiacal dust offers information astronomers can't get by observing the outer regions around other stars. Coming generations of space and ground-based telescopes, including large ground telescopes now under construction, could yield more information about the planet, perhaps inspiring ideas on how to pay it a visit.